Oh! No, no, no. Wow, Kappa. That's incredible. Dang. That's amazing. Incredible. Ah. Oh, poor Just a Human. Just a Human just never gets a break. Oh, man. Ah, shit. Oh, wow. No, there cannot be two teachers' pets. Please. Please, come on. Do you not... do you not understand how the economy works? Scarcity? Campus Wi-Fi that rivals NASA speeds. Exactly. Imagine that, B-boy. Exactly like that, B-boy. That's who inspires me. That's right. Diamonds, dude. Diamonds. Oh, don't get me started. Oh my god. Okay. 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 All right. This... Okay, folks. Trickle in. Have a seat. Virtual class. Sit down in a wherever the heck you watch this video. I don't know where you all watch class. I don't know how many of you are actually on campus, what you do, but I'm always curious what that's like. Watching Twitch on in the library. Probably kind of amusing. Okay, okay, B-boy. Okay. All right. Yeah, I think most of you are home. Watch from lobby of the dorm. I don't know what thermo is. Oh, it's a class. I don't know who that is, B-boy. Oh my God, Texas. All right. Hey. Yeah, so very few of you are doing what I'm imagining, which is you're sort of in the library watching Twitch loud, like with the volume maxed out. I sort of wish there was one of you who was doing that. Yeah. Okay, folks. I gotta do something real fast though. I gotta test you. Yeah, I gotta get my. We're gonna do some smart clicking. All right. So now 17 of you are here. That's the full class attendance usually. So I'm gonna we're gonna have an incoming problem. So go with this.
Incoming problem. Incoming problem. Incoming.
Let me set this up for you.
Incoming problem. Incoming problem.
It's a very easy problem.
Incoming problem.
I want to see if you understand the words.
Incoming problem. Incoming problem. Incoming problem.
All right. Here we go. All right, this clicking thing should have started by now. And I'll just go ahead and play some Jeopardy music. What is the third partial sum of this series? See if you understood some of the words I introduced last class. Key change. Boom, boom. How many people voted? 13? Not bad. That's 13 of the usual good students in the class voting. That's great. 73, 74. Wow, amazing. Incredible. Incredible participation. That's great. All right, I'm going to stop it there. And 31% of you are clicking my face again. Doesn't show up by design. All right. That's really funny. But yeah, 29% of you clicking the face. All right. So yeah, I'm going to stop it there. Oh, there's some controversy. Hold on. I got to wait. I got to wait. I got to wait. I got to wait. Wait, how do you 17% of you still are having some confusion. All right, so I got to stop this. Stop. Play this garbage music again. All right, answer is indeed the 60%. This is the answer. Third partial sum means easy. Add 1, 2, 3. Only do this much. Do partial. Get partial credit. Third. And then stop. Do that thing, and you should get 5/12. All right? Okay? That's all we're doing, folks. That's what partial sum means. So now, you'll know how to answer questions about the 5th partial sum, or the 4th partial sum, or the whatever. Okay? Easy. Let's go back to learning, folks. All right. What is this page? Who's that? All right, it's gone. Okay, so today I want to finish. I want to finish my spiel on geometric series. Class, geometric series are very, very special, delicate little things. Okay? Not all series are geometric. Only the ones that have a common ratio among the successive terms. Okay, so here's how you write all of them. And the Frog and Archimedes series, those are all geometric. Now what I'm going to confirm for you is that the geometric series that a geometric series converges precisely when the common ratio in size is smaller than 1. All right? So that's the first thing I'm going to do today. And that thing comes down to just an algebra fact. All right? So let's do that. Let's investigate this. Oh, after I do number 1, we'll then learn about stupid YouTube clickbait videos. Okay? But we have to learn 1 first. 1. Okay. Remember, a series converges precisely when the sequence of partial sums, first partial sum, second partial sum, third partial sum, which you just calculated, fourth partial sum, fifth partial sum. Smash Time Fools, great luminary, awesome mathematician in the chat, respect. Sixth partial sum, write that down, put a comma. Seventh partial sum, etc. When the sequence of partial sums converges to a limit. Okay? And so we're going to investigate using that. That's the definition of convergence. So we're going to investigate a geometric series using this, recalling this definition. Okay? So let's look at a geometric series. Oh, look at it. It's like a plus a times a number plus a times the number squared plus a times the number cubed. All right? Okay, dot, dot, dot. I know there's a dot, dot, dot. But what if we were to do the partial sum up until here? Let's look at this partial sum. Go until a spot and stop. This is the 6th partial sum. 6. Get it? 6. Okay? Good. Let's stop there. Let's just put that on the page. It's like an algebra thing. Look, it's algebra. Now you just have algebra. No more calculus, because there's no infinity happening here. Okay, here, let's just copy paste that. Let's stare at this. Okay, first you can factor out the a. Okay, first you can factor out the a. Okay, so the first thing I want to share with you, is an algebra fact. Now in algebra, you only use x's, right? You can't use r's. That's not allowed. So I'm going to write down a identity. When you add up just all the monomials up until 5, it turns out you get the following. Okay? You get this. Now, why? Why do you get that? Okay, that's easy. Here's why. Why? Because if you cross multiply this, multiply that across, look what happens. Look what happens, okay? Every time something happens, something else cancels it out right away. Okay, look. Foil it. Yeah, foil that. And you get, look. This x times that 1 gives you like x. But then right away, right afterwards, this minus 1 and that x, boom, gone. All right? By the way, this minus 1 and this positive 1 starts off as a minus 1, and there's no way that it's going to get canceled afterwards. So you're going to have a minus 1. The x is canceled. Look. And then, look at x squared. Look how you get x squared. You can get an x squared like this. And that's a positive x squared. But then, look, the positive x squared get canceled with that x squared. Boom. Done. X cubed will get canceled. X4 will get canceled. X5 will even get canceled. But x to the 6th is achieved only one way. Last. Outermost. Positive x to the 6th remains. In other words, when you multiply 1 plus ... times x minus 1, cancel, and you'll just get x to a huge power minus 1. There, done, proof, easy. So, this is x to the 6th minus 1. And there's nothing special about 5, folks. If it was 100, okay? Easy. Very easy. All right. So what am I going to do with this? A good question. Lol, x to the 5th, 4th. It's there. Okay, good. So in other words, we achieved this identity, this kind of algebra identity. All right. So here's what I'm going to do now. What will I do? I will... that I'm trying to do here. All right. So a times 1 plus r squared plus r cubed plus r to the 4th plus r to the 5th is a times r to the 6th minus 1 over r minus 1. Okay? And now, what am I gonna do? I'm going to, oh, that's right. I'm going to multiply, I'm gonna do some algebra on the right-hand side. I'm actually gonna swap these two. Swap them around, just for fun. And then what I'm going to do is I'm going to extract I'm going to split the fraction up into two parts. A little bit of hearts in the chat. See, I distributed the A and then I split the fraction up. Okay, that's it. That's what I want to show you today. Because what this is the sixth partial sum. So now let me write down the capital N partial sum. Let's write the capital N. All of them, all at once. Nth partial sum. Right? There was nothing special about the 6. If you do it with a 100, you'll get 100 there. If you get a 5,000, you'll get a 5,000 there. There meaning right here. Okay, fascinating. And so, what does it mean for a series to converge? It means you write down the partial sums and then look at the limit as you crank the sum to infinity. So we should look at. Consider the limit as the partial sum index. Which partial sums are we looking at? The 10 trillionth, the 10 trillion in first, and this thing of Sn. Look at this. We got to look at this limit and ask, when does the limit exist? And when does it not exist? Okay, let's do that. We know what the Sn is. It's right here. I just conveniently wrote out every single one of them for you. All right? And we got to ask, when does this limit problem actually yield a finite result? And if we can find it, can you find that finite result if it exists? All right. So this limit I claim now. If the size of R is smaller than 1, then this limit exists. Students, don't get confused. A and R are fixed on us. They're just one number. A is one number, R is one number. It's like A is 5, R is 1/7, -1/7, +1/7, whatever. They're fixed in this math problem. What's varying is the capital N in this limit. That's what's getting cranked in the limit. A is a fixed number, R is a fixed number. Okay, so you look at this and you ask, what happens if R is a small number, smaller than 1? If R in absolute value is smaller than 1, then R to the 10 trillion, and then R to the 100 bazillion, etc. These numbers, if R is smaller than 1, they go to 0. If the size of R is smaller than 1. Like 2/3. 2/3 and then 2/3 of 2/3. And then 2/3 of 2/3 of 2/3. You'll end up with 0 pizza. All right? So in other words, if R is less than 1 in utter magnitude, then the second term, it's just some fixed numbers times R to the N. The R to the N part tends to 0, only when you have this. And if you don't have this, if you're on the other side, then that term doesn't go away. It actually will explode if R is more than 1. That term will explode to infinity, and this limit has no hope of existing. All right? So that's where the r smaller than 1 condition comes in, swoops in. It gives you that this limit converges, you get a convergent limit exactly when you have this less than 1 situation. All right, so this part goes to 0, and so you're left with conclusion, which I claimed last time. A geometric series converges precisely when that number is small. Because if not, this limit will not exist. This part will not tend to any definite amount. And so you won't get a convergent limit problem in that partial sum limit calculation. So you get it precisely when this is less than 1, and in this case, this geometric series adds up to this, a over 1 minus r. The limit calculation will just output a over 1 minus r. So this is what using the limit convergence of partial sum definition looks like in the case of a geometric series. We can actually do it 100% accurately, find exactly when the limit exists, and when it exists, find what the ultimate infinite summation answer is. It's a over 1 minus r when it exists. Okay, so geometric series, we sort of have complete understanding. Let me do a classic example. So let's do a classic example. You've probably seen this. It's probably like on some, maybe it's in some YouTube video. You probably heard about it. Here's a geometric series. Why is this a geometric series? It's because each term is obtained from the previous by a fixed multiplication. Oh, Professor Peter's here. Shout outs to Professor Peter. Ask Professor Peter all the questions. Okay, good. All right. Awesome. So, this is geometric. See, there's a first term. Let me write it. First term is 9/10. And the common ratio is 1/10. It's clearly a geometric series. See that? A 8 times R, 8 times R. Okay, good. Now, let's see. Is the common ratio smaller than 1 in size? Check. Is R less than 1? Yes. Therefore, this series converges.
Wow.
Attention.
Wow.
But this is a different series, but it's like this, you know, it's one of these.
Wow.
Yes. What does it converge to? Converges to A over 1 minus R. All right. Now, why is this cool? Because if you write out this number, this is like 0.9 and then 9 and then 9. See, this is 0.99999 equals 1. These are the same number, folks. you've seen this before. Some cereal box, something. Oh, look at this. I'm so smart. Yeah, 0.99999 repeating is the same number as 1. All right? It's just a geometric series, folks. Oh, just a human guy like that? That's good. That's good. Awesome. Not approximately. It's exactly equal. Tori, it's exactly equal. Not approximate. There's a dot 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 here. It's not approximate, Tori. It is equal. This is... Dot 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 means all of it. Okay? When we say add up the series, you're adding all of it, not your favorite partial sum. Tori, I agree. Oh, partial sum number 39? That's, that's not equal to 1. The whole thing, the whole series, infinity, needs to fit in your brain. Add up the whole thing, you end up with the answer, which is 1. Good. Right? The frog never reaches 2 in finite time, but the ultimate place where it's converging to is the number 2. It gets infinitely close to number 2 as time goes on. So at the end of the day, where is it approaching? There's one definitive place it approaches at the end. And that's 2. So in this case, this weird frog approaches 1. Closely equals 1, but the closeness is 0. 0 closeness at infinity. Correct. It's off by 1/10 raised to the negative infinity power. That's right. That's right, Professor Peter. And what is 1/10 raised to the negative infinity power? Or positive infinity power? Positive infinity, probably. 1 times 10 to the negative infinity. Yeah, what is that? That's a good number. You have to round to the 1 billionth position. No. You round to the... Billion is a small number, Tori. Billion is so small. Compared to infinity, billion is 0% of infinity, Tori. So, even more. Okay. Billion is a very small number, Tori. Okay. Awesome. So now, I'm going to write that formula down. Formula. So here we go. Part 2. I want you to grapple with this, Tori. When you first see this, you're resistant, but that's part of the learning process of getting comfortable with infinity. Like at each stage, you're stuck in a billion. And what we're claiming is that, no. As you crank a billion to forever, you will definitively converge to one particular number. And that number will be 1 and nothing before 1. Nothing before 1 is the answer, and nothing after 1 is the answer. So the answer is 1. Exactly 1. Okay, so 2. Let's learn about some pop science YouTube garbage. Okay. So students will sloppily they'll write stuff on their note cards, and they'll just write this. They'll just write, so that means that every time I see a geometric series, let me just write this real fast. Okay, so this just equals a over 1. Okay, bottom line, right? Okay, bottom line. Professor went on some big old thing about r less than 1, r bigger than 1, whatever. Bottom line is, I am busy. I gotta get to a football game. Okay, bottom line is, this thing on the left, every time I see it, just go ahead and put a over 1 minus r. Okay, this is a formula. That's all math is, formula. Don't think, just formula. Okay, yeah, okay. So then you get these people that prey on you, the one who just says that, okay? That I didn't just straw man. You. Okay, here's the problem. Let's do an example now. Now you just do an example. Okay, do example. That kid who's just trying to get through school by going to football games. they're just writing this thing down without thinking, they will then come back tomorrow and they'll say, okay, let me just try something. A equals 1, R equals 2. Okay, let's do that. Let's do that, folks. What do we get on the left-hand side? Nah, I'm just filling it in. Okay? Oh, and then let me just I got a football game to go to. Very important. 3 equals. Okay, I'm just filling it in, folks. I'm just doing this homework assignment real fast without thinking, asking any questions. 1 over 1 minus 2. Okay. Let me just fill that in. Let me do some actually, Professor hates it when he just leave things unsimplified or whatever. I don't know why, but okay, fine. Let me do some math. Okay. It's just all right. Let me just. You gotta box your answer. Okay. There you go. All right. Next problem. All right. Not problem. No. Do now. Let's just move on. Look what you just wrote. You literally wrote garbage. That can't possibly be the case. That can't possibly be the case. 1 plus 2 plus 4 plus 8 plus 16 plus 30. Humongous numbers, folks. At the end, Tori, at the end of this math problem, they're saying, the football person is saying that adds up to -1. That cannot possibly be the case. In fact, 1 plus 2 plus 4, etc. diverges. Obviously. But we're saying it's -1? No, we're not saying that. That's why you have to go back to that annoying professor and listen to what they said. The conclusion was 2 parts. 2 parts. This geometric series converges precisely when the common ratio is smaller than 1. And in this case, do you earn this formula? The handy formula has terms and conditions. In other words, warning. Moving forward in this class, a lot of times, a handy dandy formula will come with terms and conditions. Asterisks. Terms and conditions apply. Namely, make sure your R is smaller than 1. Only then does this actually make any sense. We are telling you that in advance. You're not listening. You're just writing down formulas without asterisks. So it's important to understand what we're claiming. This is a true formula only when your R is within a confined little radius. There's like a radius of convergence in which the left-hand side actually makes sense. And that radius is like 1 around origin. There's a domain of applicability. There is a region of truthfulness where this equation holds. Outside of it, it is complete garbage. We know that. We know that in advance, and we use it only when we know how to use it. Terms and conditions apply. This is a learning lesson. It's going to come back and bite us in the ass later in the class. Similar situations. Some magic formulas work, but only in certain constrained regions. We're going to have to study that carefully as the examples become more and more interesting. Okay, so that's the ending for my take on geometric series. We know how to compute all of them. The answers are either nonsense when R is too big, or They are a over 1 minus r when r is small. That's it. We know everything about geometric series. When they converge, what they converge to if they converge, and oppositely when they diverge. So applaud yourselves, be happy. Be curious about 0.99999 equaling 1 if you haven't seen it before. Dot dot dot. Dot dot dot. Infinitely many dots. Sorry. Be amazed by that. Learn to appreciate this, the subtleties of infinity. Review the story of the frog. Review Archimedes' example. Review 0.999. Review this, which is saying we can do all of them. Terms and conditions apply for the formula. Because now I'm going to move on. So let's move on. I'm going to move on now. I'm going to move on. Okay, I'll move on, but let me just first move on from the subject of geometric series. We'll be using them all the time, but let me just look at chat to see if there was any questions that are relevant to the topic of geometric series before I change topics. No, not 0.999999991. No. That will lead you to a different number. But yes, good. Can I prescribe medicine? Yes, actually, yes. That's a good point. Crow, I can prescribe medicine. So here we go. This actually does merit doctor's orders. All right, students. Okay, let me just do this real fast. Okay, students. Review how the terms and conditions before the handy formula for figuring out geometric series actually is born. Okay, and do this review 400 times. Review this 400 times this week. Usually during lunch breaks, showers, ball games, etc. Okay? So do that 400 times this week. Don't wait till next week to completely understand the subtlety of that formula, the terms and conditions, the notion of convergence and divergence. Good. All right, so I prescribed that. Okay. So moving on, folks. Moving on. So you have your first homework that's due. Hey, what is going on here? Okay, first homework is due on Wednesday. You have an exam, by the way, at 1. You have your exam at 1. It'll just be about sequences and very basic stuff about a geometric series. It's an easy exam. This exam is easy. Okay. But on Wednesday, you have your geometric series and other kinds of series homework due. So to move on, we're going to sort of study, for reasons that are never clear to me, which elude me. Always. We're going to study another type of series. Geometric series, very useful to have in your tool belt, especially when you need to compare with some other series. Maybe some other weird series comes our way. We don't know whether it converges or not. Maybe we can pit it against a geometric series and figure something out. That's very common. This garbage? Okay, so we're going to study another type of series. Just because it's on a homework. Called telescoping series. Now, telescoping series are kind of hilarious, okay? So the idea of a telescoping series is easy. Okay, so here's the idea. Here's the idea behind telescoping. Really dumb, okay? So it's one of the dumbest things I've ever seen. Okay, look. Hey, class. Check out this series for some reason. Okay, let me write this in Sigma notation, which we should practice. I also will have office hours tomorrow. We should practice a lot. Okay. Okay, there. This series. Wow. Hold on. Is it geometric? Let's see. To go from the first one to the next, you multiply by 1/3. Go from the next one to the... That's not times 1/3. So no, there's no common ratio. No common ratio. Not geometric. So we basically have no idea how to do this. Okay. But what if I were to tell you? What if I were to tell you that 1/2 is actually 1 minus a half? And then what if I were to tell you that 1/6 is actually 1/2 minus a third? Now, what if after that I were to tell you that 1/12, 1/3 times 1/4, is actually 1/3 minus a fourth? Don't believe me? Go do it. Go do it. It's actually a lot like partial fractions. Like partial fractions, folks. What if I were to tell you that this is actually, it's actually 1/4 minus a fifth? What if I were to tell you that? Now, what if I were to tell you that, oh, look at this. Look at this real fast. Now, tomorrow I'll talk about this more in depth. But look at this. Look at this. Just don't worry about anything, anybody. Just look at this. Look at this. Look, wow. Oh my God. Huge. It's a huge cancellation. See, like boom, boom, boom. And if you draw it carefully, you'll see a big telescope. You see that? Big telescope. Just cancel. It'll form this big old telescope. I guess that's why I don't know why they call it telescoping series, okay? I don't know why they're even teaching this. But here, you get this massive cancellation, but there's one number remaining. Wow, Pog. So in order to do the homework, I gotta teach you how to detect a telescoping series, how to go from that first series to this one, and then how to see that the telescoping series actually converges. I never used the word converges here, or diverges. We're gonna have to use that word one time at one point in this simplification or this calculation I just did. All right, but for now, class, I encourage you to go and actually add up the first couple partial sums of this series and see that you do get dangerously close to 1. You're starting to get dangerously close to 1. And the point is, yeah, the total sum, Tori, the total sum at the end. The total sum is just 1. Exactly 1. Not some number slightly less than 1. Not a number slightly more than 1. Exactly 1. And the method is by massive stacking cancellation, which forms a huge long telescope, I guess. And that's why it's called a telescoping series. And that's my lecture for today. Let's move on. What happened? What happened when I was away? Bunch of people followed. By bunch, I mean 2. So welcome, 2 of you. And partial fraction. Didn't you do PFD? Yeah, I did PFD, and we're gonna do PFD on Wednesday, Cap. Oh, by the way, lots of people complaining about the exams, but you know, the statistics say it's mostly good. So I just wanted to let you know that you're not all doing horribly. Doing just like previous classes are doing. So you know, it's just hard. That's all. Keep. When you do a homework problem, ask yourself, can I explain to a peer how to do this problem thoroughly? Like why you do what you do? If the answer is yes, you will be fine. If the answer is no, you might have a problem with some of the conceptual problems, but you'll still be able to do calculation problems. So that's always the litmus test. I've never had problems with low grades before, and I'm not having them now, right? The grades are not... I'm not worried. It doesn't look like some kind of train wreck. I think there's one thing though. There's some students who come in and they've just sort of been great at all the math classes ever or whatever. And maybe some of them are like, I'm not acing everything. Yeah, well, that's good. It's good that you're feeling that early college. But today's exam is easy. Okay, folks? Today's exam is very, very straightforward and easy. Don't rush it, but don't, tie yourself in knots. Just stay calm, and I'm not trying to trick you with anything. It's just easy. Easier than last exam. Easier. I know the difference. Please have a pocket protector with a calculator sleeve. Is that a suggestion for me, Pandemic? Oh, thank you, Jabber. Thank you. Yes, teehee. Yeah, maybe. I tried to put this to indicate that I'm educated, so I carry around Permanent marker? Alright, so no one, oh, Cadao! Cadao! Thank you. DHL, thank you. Jabber. Natananan, thank you. The real. Ali. Alamender. Wow. Wonderful people. Hey, you guys want credits? Let's start ending with credits, folks. Let's do credits. Let's roll the credits and then get out of here, all right? Credits. Credits. Let's do this. Kappa. Was teacher's pet again. Alright, double roll. Kappa starred in double roll. What else? Who else is out there? Who else out there? Crow. Crow. Simply because Crow subscribed with Twitch Prime, which students should never do. Alright. Alright, that's the only reason they're in the credits. Shungite, Tropical Geek. You get your Shungite. 1, 2, 3. There you go. Let the 5G stay away from you today. Okay, there's some recorders. People, these requests don't count if you're just trying to get into the credits. All right? So, okay, but Tropical usually makes it anyway. So Tropical, fine. Fine, I guess. All right, who else? Who else was a big? Professor Peter was here. Professor Peter. Ahmad takes care of business in that chat, cleans it out, clarifies everything way better, says everything fancily and with good words. Check out Professor Peter, explains things beautifully. Highly recommend. They stream. They're a professor on Twitch. Check them out. All right, Tori. Tori asks some good questions. Tori. Questions that most students don't fully ask themselves. The Tori represents the honest student. All right. Ask yourself, what does the ... mean? It means converges to. Okay, next. Who else asked? Just a human. Just a human. B-boy. For showing up. Alright. By the way, did Kotz show up today, or is Kotz playing video games? No, Kotz is not playing. Oh, you showed up too. Yeah, flushed. Alright, Sparky from Clash Royale has requested a recorder. So Sparky, I guess my rendition of the Imperial March was not enough for you. What do you want me to play, Sparky? Will web assignment homework be added to our grade at the end? The whole grade is figured out at the end, Math Mama. Math Mama, the grade is just figured out last day of the semester. Last possible minute. I do the percentages, boom, boom, boom. I look at certain people and I say, is this the grade they deserved? Sometimes the answer is no. And then I just corruptly change it. Alright, that's how everybody does it. Alright. Alright, the Link Sword. Thanks for following. Alright. No, in a bad way. I'm just like, no. This person deserves to fail. They got an A, but you know what? I'm just gonna fail them. Of course not that way. Always upward. That's scary. No! No, it's like illegal to do that. Cowboy. People just, they just don't get humor. Oh my god, you're gonna clip that out of context? Good. Then I'm gonna be fired. Just watch. What's his name? What's the football coach's name? Ted Gundy. Oh, oops. Mike Gundy. Mike Gundy. Mike Gundy's gonna gonna fire me. He runs the place, right? I always get it mixed up with Ted Bundy. I always get Mike Gundy's name mixed up with Ted Bundy, and I get Ted Gundy. Ted Bundy's someone else, folks. Don't look it up. Don't look it up. No, Crow. No. No. Not that person. Bro, I'm gonna Crow, don't say that stuff in the chat. I'm gonna have to unsubscribe you. Alright. So, what does this person want? Crow, Sparky, what do you want? Sparky wants Britney. Whatever you're passionate about, or Britney. Britney? Alright. I only know one Britney song. Because a previous class asked for it. Requested it. Do I know any? What are some other, like, can you name another song? Maybe, Teacher's Pet does not help you get any kind of brownie points. It's purely, points are made up and, yeah. All psychological. Megalovania. Oops, okay. I can't do this. I can't, it's too low. I started too low. Wait. Okay, I'll redeem. Okay, that was one. I'll do the other one. Hold on. Okay. Let me try it again. Okay, I'll stop. Okay, folks, I gotta go. I made my wife mad. Again. Okay, I'll stop. Okay, I'm stopping. Jeez. Every time I just sit down and start to play Britney and just every single time.